In the previous topic, we mentioned garbage collection in connection with the memory heap. In a language like C, we have to allocate and release memory. Well, that's not so in JavaScript, but there still needs to be a mechanism for reclaiming memory so we don't run out of memory and crash the system. JavaScript handles the reclaiming of memory for us. Once a piece of information, an object or a variable, is out of context and won't be used anymore, its memory is reclaimed so it can be reused. This is called garbage collection. Let's take a look at how that works in the engine. Garbage collection takes place in the memory heap, and it uses what is sometimes called a mark and sweep algorithm. It determines the objects that can be safely deleted from the memory heap by determining which things are reachable and which are unreachable. And then it sweeps through those that are unreachable. They are swept off and that memory is reclaimed. Let's take a look at how it works. Now, the garbage collector starts with the root or global object and moves to the objects referenced by them. And it moves from one object to another, identifying things that are referenced by something else. So basically, those things which are reachable and those things which are not reachable are now defined. And then everything that is unreachable, we now see a few things which are not linked, are not reachable. Everything that is unreachable is cleared. It goes through and sweeps those off. They're gone. That memory can now be reclaimed and used for something else. Now, as you notice in our explanation, in order for information to be freed up and reclaimed, it must not be connected to anything currently going on in the program. Unreachable. Well, it is possible for our coding to keep things from being reclaimed even though we are no longer using them. This is called a memory leak. Memory leaks are parts of memory that the application needed and used in the past and is not needed anymore, but its storage is yet not returned to the memory pool. Even though garbage collection is handled for us, as we've seen, we still need to be cautious of memory management. Memory leaks can cause JavaScript programs to fail by using up all of the available memory. Let's look at some common things that can cause memory leaks. So first off, global variables. If you keep creating global variables, they will stick around throughout the execution of the program, even if they are not needed. If these variables are deeply nested objects, a lot of memory can be wasted. Not removing event listeners that are no longer needed. As one example of how this particular thing can happen, you could create a lot of event listeners for a particular page or location. And then when the user moves past that, where those event listeners are no longer needed, you as a programmer don't remove them. They're still there. They're still taking up memory, especially for the objects they're linked to. So something to be aware of. The third item, uncleared time intervals. Now, set interval is a good example of this. And if you haven't used set interval, basically what it does, it allows you to execute some code over and over again based upon a set amount of time. Now, let's look at a really quick example of this one. I'm just going to call set interval. And set interval takes as the first parameter a function. This is a callback function. So every time the interval expires, the amount of time we enter, it invokes this callback function. So I'm going to set up a function here. And then the second parameter is the amount of time in milliseconds that each interval happens. So every 200 milliseconds, this function is going to be invoked. Okay. Now, where this can become a problem is, say, inside of here, we reference a number of objects. So those objects are being referenced there. And sometimes this kind of thing is done with animation or something like that. But if this is never cleared, if this set interval is not cleared, obviously these references are still going to be valid, and so it will never be able to free up that memory, even if it's no longer being used. So a better approach to the set interval problem is declaring an ID, and we set that equal to set interval. That will place an ID inside of here. Then when we are done, we should make sure that we clear interval with that ID, something like that. Okay, one more thing we need to mention, and that's removed DOM elements. If in your program you remove elements from the DOM, but these elements are still referenced, such as with an event listener, we talked about that earlier, or in some other way, the memory will not be freed up. So something else to be aware of. Now, we will revisit some of these in other places in the course so that you have a reminder of best practices to prevent memory leaks. All of these things we've talked about can add up, and the memory leaks will continue to take more and more memory. If your program runs long enough, it could eventually fail for lack of memory. Even if it doesn't fail, you should make sure to avoid memory leaks and not just rely on garbage collection to save the day. All right, let's move on to the next topic.